Hello everyone, just wanted to provide a proof of the angle side theorem, which is one of the 5 methods that we use to prove that triangles are congruent. So notice we have 3 postulates, the side, angle side, and angle side angles methods. These are all postulates, whereas the angle side theorem and hypotenuse leg theorem are theorems. And the difference here is that a postulate is something that can kind of be reasoned to without any kind of formal proof required, as opposed to a theorem, which actually does require a proof. So we're going to prove this theorem, and I'm actually going to end up using this postulate in order to do it. So as with any proof, let's take a look. We're given that we have these 2 triangles, triangle RED and triangle BLU, and we have some congruency markings here. So we always want to start each proof by kind of restating the given information, and then now we're going to go through and prove that these 2 triangles are congruent. So this is going to be kind of a longer proof than some of the other ones I've done, because a lot of the technical steps, like this one here, the first thing I need to do is I need to say that the measure of angle R is equal to the measure of angle B, and the measure of angle E is equal to the measure of angle L, and I get to make both of these claims because this is the definition of congruence. Definition of congruence here. Now I need to make another couple of claims to get set up here. I need to say that all of these angles in both triangles add up to 180 degrees. So that would look like the measure of angle R plus the measure of angle E plus the measure of angle D is 180. Same thing with the other triangle. Measure of angle B plus the measure of angle L plus the measure of angle U is equal to 180. I get to make both of these claims because these are angles inside of a triangle, and that is the triangle angle sum theorem. Okay, now that I've got that, well, all of these angles add up to 180, and all of these angles add up to 180. So I can use the transitive property to set those angles equal to each other, because that's what the transitive property says. It says that things that are equal to the same thing are equal to each other. So we'll write a kind of a big equation here. Measure of angle R plus measure of angle E plus measure of angle D is equal to measure of angle B plus measure of angle L plus measure of angle U. Kind of run out of room there. But I just set all the angles of the triangle equal to each other, and now I can use substitution because we have angles that are congruent. So what I'm going to do is use the substitution property to replace angle R with angle B and replace angle E with angle L in this equation. So that would look like measure of angle B plus measure of angle L plus measure of angle D is equal to measure of angle B plus measure of angle L plus measure of angle U. Still running out of room there. Okay, well now notice I've got B's and L's on both sides of the equation. So if I use subtraction now, then I could subtract away both of those angles, and I'm left with the measure of angle D on this side being equal to the measure of angle U on this side of the equation. Well, if their measures are equal, then that means that those angles are congruent. Angle D is congruent to angle U because, again, this is the definition of congruence. definition of congruence says things are congruent if they have the same measures. Okay, so angle D and angle U are congruent. Let's go ahead and slap those congruency markings on there. And then now, what do we have? I have two angles and a side in between them matching up with two angles and a side in between them on another triangle. I can go through and claim now that triangle RED is congruent to triangle BLU because of the angle side angle postulate. And so now that we've proven this, there's no need to go back and add in the extra congruency marking and use angle side angle. Now we can use the angle angle side theorem to prove that triangles are congruent. So like I said, kind of a lengthy proof, but there it is.